Okay, so let's start the review for test number 4. Let's start right away with 1 through 4 right here. It says, for 1 through 9, decide if the system has A, one solution, B, infinitely many solutions, or C, no solution. Okay, so let's start with number 1. My options once again are A, one solution, B, no, infinitely many solutions, or C, no solution. Number 1 says, you solve a system by graphing and find that the lines are parallel. So what would that look like? That would look like two lines, right, that never intersect. Two parallel lines, they never intersect. So what does that mean? Remember, a solution to a system is the point where the two lines intersect. This point right here in this system right here that I just drew, that's the solution, the point of intersection. But in a situation where the lines never intersect, as in parallel lines, the ones that I have right here, there's two parallel lines, they will never intersect, which means that they will never have a point of intersection, which means that they will have no solution. The answer to this one is C, no solution. All right, moving down to the number 2. You solve a system by elimination and end up with the equation 0 equals 0. We practiced this a few times. You solve the system by elimination. You have 2x plus 3 equals 7 or whatever you have. But at the end, once you do the elimination, you end up with 0 equals 0, as it says right here. Okay. At that point, you have to question if the statement is true or false. Because I see in my equation that there is no x or y, right? The variables have both been eliminated. So you look at the equation that you have left over and you ask, is it true or false? Now this equation is true. 0 is equal to 0. Therefore, since the equation is true, you will say this has infinitely many solutions. Oh, I don't have to write it out. Infinitely many solutions, that's option B. That one's B. Okay, number 3. You solve a system by substitution and end up with the equation x equals 3. Now you didn't end up with 0 equals 0, okay? You didn't end up with something that makes no sense. You didn't end up with 0 equals 10. You actually ended up with x equals something, okay? Now at this point it doesn't really matter what the y is going to be equal, but we found a value for x, okay? So since you did find a value for x, that pretty much tells you that there is a solution to this system, okay? And it's not going to be infinitely many solutions because you didn't end up with 0 equals 0 or 2 equals 2 or something that is always going to be true. This is true, x equals 3, but only for this particular value of x. Therefore, there is only one solution, A. Okay, let's move down to number 4. You solve a system by graphing and find that the lines intersect. Well, that's the first example that I said before, right? You have two lines. Here's one, here's the other, and they do intersect at a particular point right there, which means that they have one solution. My answer here is C. No, A, one solution. Okay, so why don't you go ahead and try numbers 5 through 9 on your own. Okay, so pause the video right here, try them on your own, and then unpause it once you want to go ahead and check your answers, okay? And I'll have the answers for you guys. But first, try them on your own. Okay, go ahead and pause the video right now. Okay, let me go ahead and give you the correct solutions here. Number 5 is no solution because 0 equals 5 is false, right? The variables were eliminated. Number 6 is infinitely many solutions. Both variables are eliminated, but you ended up with something that is true. Number 7 is infinitely many solutions. If the lines coincide or they are identical, that means they're one on top of the other, which means that they're always going to intersect, so there's infinitely many solutions. Number 8 is A. There's only one solution because x equals -4. All you got to do to find the solution is go ahead and take the x equals -4 and plug it into either one of the two equations. And number 9 is C. No solution because once again you ended up with a statement that is false always. Okay, let's move on to number 10. Solve each system of linear equations by graphing. And it says x plus y equals 3 and negative x plus y equals 1. Now I know we learned other methods like elimination and substitution, but I don't want to use those right now. I'm going to use graphing. That's what the problem is asking me to do. Okay, so let's use graphing. what I'm going to start with is I'm going to take this first equation and I'm going to put it in slope-intercept form, right? I'm going to put it in y equals mx plus b form. It's going to change into this form. Okay, so in order to do that, I'm going to take the x plus y equals 3. I am going to isolate the y. To isolate the y, you need to subtract x from both sides. When you subtract the x, you get y equals negative x plus 3. You cannot combine the 3 and the negative x. That would be a very bad mistake to make. That would be a rookie mistake right there. Okay, so write them separately, negative x plus 3. Okay, that one's done. Do the same thing to the other equation. Okay, so negative x plus y equals 1. Here, I need to isolate the y also, so what I'm going to do is instead of subtracting x, I need to add the x because that would cancel it out. That would eliminate it. So I'm left with y equals x plus 1. And there's my two equations. And now I can go ahead and graph them. Okay, so the first one, y equals negative x plus 3. What I need to do from this one is figure out what the slope and the y-intercept are, m and b. The slope is the coefficient of your x if it's in slope-intercept form, right? Find x, and whatever is next to it, the coefficient of it, that's your slope. So in this case, it's negative 1. The y-intercept is this number at the end, right? Y equals mx plus b. This b number over here at the end, that's your y-intercept. So in this case, it's 3. For the other equation, the slope is the coefficient of x. So in this case, it's just a single 1, right? There's a 1x right there. So m equals 1. And your y-intercept is also 1. It's this number over here at the end. And now you can graph. So let's graph the one that I wrote first, the black one. M equals negative 1 and b equals 3. To graph this, what you do is you begin at the number 3 on the y-axis. That's the y-intercept. And then the slope is negative 1. Okay, so to figure out how to move using the slope, turn the slope into a fraction real quick, which is basically negative 1 over 1. And those are basically directions on which way to go. It's telling me to go down 1 and to the right 1. So from that point, I'm going to go down 1. From this point right here, I'm going to go down 1 and to the right 1. Down 1 and to the right 1, and so on, and I could draw my line. So down 1 to the right 1, I end up here, then here, then here, then here, then here. There is no rule that says you only have to do 2 points. Make as many as you need to make your line straight, especially if you don't have a ruler handy. Okay. So then I connect these points and I have my line. There it is. Now to do the other graph, the beginning or the y-intercept is positive 1, so this time I'm going to start at positive 1, right? B equals 1, so I start at positive 1. And my slope is 1, which as a fraction is 1 over 1. So those are my instructions. Go 1 up, 1 to the right. 1 up, 1 to the right. So from that point, I'm going to go up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right, and so on. So from here, 1 up, 1 to the right, I end up right there, right there, right there, right there, right there, right there, and I can draw my line now. There you go. So where is my point of intersection? The point of intersection you can see is right here where the two lines meet, which the value of that point is positive 1, positive 2. So my solution is 1, 2. And I am done. Okay, so you go ahead and try number 11 on your own. Okay, so go ahead and pause the video right here, try it on your own, then come back and watch the correct solution. Okay, go ahead and pause the video now. Okay, so here's the correct solution for number 11. You take the first equation, it turns into y equals negative 2x plus 4 in slope-intercept form. So the slope is negative 2 and the y-intercept is 4. The other equation turns into y equals negative 2x plus 6 in slope-intercept form. So the slope is negative 2 and the y-intercept is 6. So now, when you graph them, you can see that the two lines are parallel. They're never going to cross. That makes sense because their slopes are the same. So they have the exact same rate of change, but they begin at different points, right? The y-intercept here is 4, and over here it's 6. So they begin at different points, but they have the same slope, the same rate of change. So they're never going to intersect. They're parallel, which means that there is no solution. All right, let's do number 12 together. It says Jill babysits and earns Y dollars at a rate of 8 per hour, plus a $5 transportation fee. Samantha babysits and earns 2 Y dollars at $16 per hour, plus a $10 transportation fee. Write a system of equations and graph to determine the number of hours each needs to babysit to earn the same amount of money. Okay, so let's start writing the equation for Jill. Okay, so just for Jill right now, I'll write it right here. Okay. Jill, it says, babysits and earns Y dollars at a rate of $8 per hour plus a $5 transportation fee. Okay, so I have two variables here, two items that are changing. The number of hours that she works and the amount that she earns. Okay, they're telling me that the amount that she earns is Y, because it says Y dollars is what she earns. So we're going to call X the number of hours that she works. Okay, so if she's working at $8 per hour, in algebra we say that that is 8x, right? Per hour multiplied times the number of hours, 8x. Plus, on top of that, there is a $5 transportation fee. That is a one-time thing. You don't multiply that times anything, okay? And when you do that, 8x plus 5, it gives you the total number of dollars that she makes, which is Y, as they have told me. There's the equation for Jill. For Samantha, it's going to be very, very similar. Samantha earns 2 Y dollars, so she doesn't make Y dollars, she makes 2 Y dollars. And she makes that money from $16 per hour plus a $10 transportation fee. So Jill's equation is ready to graph. It's already in slope-intercept form, so I'm going to go ahead and graph that one. In this one, the slope, well, let me do that one in black. In this one, the slope is 8. I'm going to write it as a fraction as 8 over 1. And the y-intercept is 5. For Samantha, though, the equation is not ready. It says 2y equals 16x plus 10. So that's not slope-intercept form. It should be y equals something. So we're going to simplify it. We're going to solve for y. And it's very simple here. All you got to do is divide by 2. And that leaves the y by itself, right? That's the goal. Isolate the y. 8x plus 5. So therefore, the slope in this one is 8 over 1. And the y-intercept is, once again, 5. So if I graph that, for Jill, I begin at 5, which is approximately right here, below 6. And the slope is 8 over 1, so I'm going to go up 8 and to the right 1. So from 5 to go up 8, that's going to be all the way up to 13 and to the right 1. So somewhere around here. And I could keep doing that. I could keep going by 8. So from 13 to 8, I go 21 and over 1, and so on. I could keep making points like that. So my line will go something like that. For Samantha, I begin at 5, same point as Jill, and I go up 8 over 1, same thing as Jill. So look at that. What happens when that happens is that I'm going to get the exact same line, right? It's the same line on top of each other. Okay, these lines are identical, they coincide. Okay, therefore this has infinitely many solutions. So what does that mean in this situation? It says determine the number of hours each needs to babysit to earn the same amount of money. It doesn't really matter. They will make the same amount of money for any number of hours. For any number of hours that they work, they will make the exact same amount of money. Okay, you could test that by plugging in any numbers you want. Plug in 2 into Jill's equation, for example. Say she works 2 hours. 8 times 2 is 16. 16 plus 5 is 21. Okay, Plug in 2 into Samantha's equation and solve for y, and you will also get 21. Okay, let's continue with 13 and 14. It says solve each system by substitution. Check your answer. Okay, so let's start with number 13. I have a system of two equations, y equals x minus 2 and y equals 4x plus 1. When I'm going to solve by substitution, I always like to separate out the equations. Okay, so write them separate from each other. Y equals x minus 2, and over here I'm going to write y equals 4x plus 1. You don't have to do this the way I'm doing it by separating them out. It just helps me keep track of what I'm doing if I separate them out when I'm using substitution. When I'm using elimination, I don't do this. I want them to be together. Okay. So y equals x minus 2 and y equals 4x plus 1. What I do is I look at each equation and I try to isolate one of the variables. In this case, I don't have to do that step because the y is already isolated here. Also, the y is already isolated here. So it doesn't really matter where I start. Both of them have a y that is already isolated. Okay. So if I want to use substitution, what I'm going to do is take one of these two equations that is already solved for me, take the expression that it equals to, and I'm going to take that expression x minus 2 and I'm going to substitute it into the other y on the other equation. Okay, so it's going to look like this. This x minus 2 is going to replace the y, and everything else will be the exact same thing. See that? That y got replaced by x minus 2. Okay? And now I only have an equation with only one variable, and I can finish it and solve it. X minus 2 equals 4x plus 1. I am going to subtract x from both sides. Right? I want to solve for x here. So I'm going to subtract x from both sides. You can also subtract 4x from both sides. It's your choice. I'm left with negative 2, 3x, plus 1. I'm going to subtract 1 from both sides, and I'm going to end up with negative 3 equals 3x. And finally, I'm going to divide by 3, and there's my x value. X equals negative 1. Okay? At this point, what you do is you take this x equals negative 1, and you go back to either one of the original two equations, and you plug that in. Okay? So I'm going to go ahead and plug it in into this equation right here. Y equals x minus 2. I'm going to plug in negative 1 right there for x. So now it's going to look like this. Y equals negative 1 minus 2. Because the x is negative 1. And so I'm going to end up with y equals negative 3. And there's my solution. My solution is negative 1, negative 3. Okay. Finally, it does say to check your answer. So I'm going to go ahead and do the check. Okay. So I'm going to erase this work so you guys can see how the check works right now. Okay. Here we go. I want to check that negative 1, negative 3 is the actual solution to this system of equations. So what you do is you take the negative 1 and the negative 3 and you substitute it into both equations to see if it makes it true. So here's the top equation. Y equals x minus 2. And for the y, I'm going to plug in negative 3. And for the x, negative 1. And I'm just going to check that I actually get an equation that is true. Negative 1 minus 2 is negative 3. Good. Check the other one. Y equals 4x plus 1. Plug in negative 3 for y and negative 1 for x. That leaves you with negative 3 equals negative 4 plus 1, because 4 times negative 1 is negative 4, which leaves you with negative 3 equals negative 3, and check. Again, that is true. Therefore, this solution is correct. Okay, so go ahead and try number 14 and 15 on your own. Okay, so pause the video here so that you can do it on your own and then come back and check your answers, because I'll have the solutions for you guys right here. Okay, go ahead and pause it now. Okay, so here's number 14 and number 15. Number 14 is 3, negative 1, and number 15 is 2, 7. Just real quick, you can see the work right here. Here's the first equation, number 14, and the second equation. I took the x minus 4, substituted in for y right here, solved all the way down until I got x equals 3. I took that x equals 3, went back to the other equation, plugged it in, and I got y equals 3 minus 4, which is -1. There's my solution. Okay. In number 15, here's the two equations, y equals 3x plus 1 and y equals 5x minus 3. I took the 3x plus 1 and I substituted in for y right here. So I got 3x plus 1 equals 5x minus 3. Solved all the way down till I got x equals 2. Took it back, substituted into 3x plus 1, got y equals 7. There's my second solution. Okay, now let me show you what happens when the equations are not already solved for one of the variables. Okay, so let's do number 16 here. 2x minus y equals 6 and x plus y equals 3. Once again, like before, I'm going to split them up because I'm trying to use substitution here. So I'm going to write 2x minus y equals 6 right here, and over here x plus y equals -3. Then what I'm going to do is I'm going to look at both equations and figure out which equation first, and then which variable am I going to isolate in that equation. Okay. So in the second equation, I see that the coefficients are 1 and 1. I like that. The smaller the coefficient, the better it is going to be for you. Okay. In the first equation, my coefficients are 2 and -1. -1 is fine. I could isolate for that variable right there with the -1, but the negative is always going to give you guys some of you guys a little bit of issues. So it's better to go with the second equation and isolate either the x or the y. It doesn't matter because they both have a +1 in front of them. Okay, so let's go with the second equation, and I'm going to be isolating the x. Okay, so if I want to isolate the x in this second equation right here, I'm going to subtract y from both sides, which will leave me with x equals -y minus 3. Okay, you're going to take this -y minus 3, that expression right there, and you're going to take it over here to the other equation, and you're going to substitute it in right there for that, not for the y, for the x. Let me redo that arrow. You're going to take it over here and substitute it in for the x right there. Okay, why for the x? Because I solved for x, I didn't solve for y. Okay, so let's take that first equation right there and solve it using -y minus 3. So it's going to look like this: 2x minus y equals 6. Instead of x, I am going to substitute in -y minus 3. And now I'm going to clean it up by distributing and isolating the variable. Okay, so let's distribute the 2. 2 times -y is -2y. 2 times -3 is -6 minus y equals 6. I need to combine the -2y and the -y here, giving me -3y minus 6 equals 6. Now what I'm going to do is add 6 to both sides. That's going to leave me with -3y equals 12. And now I'm going to divide by -3. And that leaves me with y equals -4. Okay. You're going to take that y equals -4 now, and now you're going to go back to the first equation, or actually you could go back all the way to the equation that you're already using. So I'm going to go back to this equation and plug it in right there for the y. Okay, so it's going to look like this: x equals -y minus 3, but instead of y, I am going to substitute in -4. So it's going to be x equals 4 minus 3, which is 1. There's your solution. My solution is 1, -4. Okay, and once again, I'm going to go ahead and check my answer here. Okay, so to check my answer, what I'm going to do is substitute in x and y into both equations, and both have to be true. Okay, so I'm going to go ahead and erase my work right here so you guys can see the check. Here we go. Okay, so I'm going to start with the first equation. 2x minus y equals 6. Instead of x, I am going to substitute in 1. And instead of y, I'm going to substitute in -4. And I'm going to check if this is actually true. 2 times 1 is 2. minus negative 4 turns into plus 4, right here, equals 6. And you can see that this is true. 2 plus 4 is equal to 6. Check the other one. X plus y equals negative 3. X is 1, y is negative 4. 1 minus 4 is equal to negative 3. And again, you can see that that's also true. 1 minus 4 is negative 3. Therefore, that is the correct solution. Okay, I'm going to let you guys go ahead and do 17 and 18 on your own. Okay, pause the video right here and then come back once you have done both of these and check your answer. Okay, so pause right now. Okay, here you go. These are the correct solutions for number 17 and 18. 17 is 4, negative 3, and 18 is 3, negative 2. In 17, one of the equations was already solved, so I took this equation, the x minus 7, and I substituted it into this other equation for y. Then I solved for x, found x equals 4, and then substitute that in again, and found that y equals negative 3. In number 18, I solved the second equation for x, so I got x equals negative 2y minus 1. And then I took that expression and substituted it into the first equation for x right there. Solved for y, got y equals negative 2. Plug that into either one of the original two, and I got x equals 3. Those are the correct solutions. Okay, let's do this again. Go ahead and try number 19 and 20 on your own. Pause the video right here, and then come back once you have the answers that you think are correct to check your work. Okay, go ahead and pause the video right now and try number 19 and 20. Okay, so here are the correct solutions for number 19 and 20. Number 19, x equals 1 and y equals negative 2. And number 20, x equals negative 1 and y equals negative 2. You can see some of the work right here. If you wish to pause it to see some of the work, go ahead. But the basic idea is that I took the second equation in number 19, solved for x, so I got this, substitute that into the other equation. Eventually, I got y equals negative 2. Took that y equals negative 2, plugged it in over here, and I got x equals 1. In the second equation, in the second system, I took the first equation and solved for y. So I got y equals 2x. Took that 2x and I substituted in right here for y in the second equation. Okay, solved all the way down to get x equals negative 1. Took that x equals negative 1, went back and plugged it in to get y equals negative 2. Okay, once again, I'm going to let you try this on your own. So try number 21. Go ahead and struggle with it. I know you guys are probably scared of these fractions, but try it out on your own. Pause the video, then come back and see what the correct solution is. Okay, just to give you guys a hint, you can see clearly that there's a y right here that only has a coefficient of 1. So take that equation and solve for y. Okay, and then try to do everything else that you're supposed to do. Go ahead and pause it now and do it on your own. Okay, here we go. Let me show you guys not just the correct solution, but how to arrive at that correct solution. Okay, so I'm going to split them up like I've been doing. So the first equation is 1/2 x plus 1/3 y equals 5. And the second equation is 1/4 x plus y equals 10. Okay, I noticed that the second equation, you know what, let me do it in a different color so you guys can see it clearly. I realized that in the second equation, the y only has a coefficient of 1, right? You can see right there. So I'm going to take that equation and solve for y. All the other ones would be a little bit more difficult to do, but that one already has a coefficient of y, so it makes my job a little bit easier. Okay, so I'm going to solve that one for y by subtracting 1/4 x from both sides. What ends up happening is I get y equals negative 1/4 x plus 10. I can't combine those together, so it's just going to be two separate terms, negative 1/4 x plus 10. I'm going to take that negative 1/4 x and I'm going to substitute it into this equation over here in for the y because I solved for y. Okay, so it's going to look like this. 1/2 x plus 1/3 y, instead of y I'm just going to put parentheses there, equals 5. And what am I going to put inside those parentheses? what the expression that y is equal to. Y is equal to negative 1/4 x plus 10. So I'm going to take this negative 1/4 x plus 10 and put it in right there. Hopefully it fits. Like that. Okay. Actually, let me expand it so I can clean it up because it does look messy right here. Okay, let's fix that. Plus 1/3 parentheses equals 5. And then inside those parentheses, I put negative 1/4 x. That should give me more space. Plus 10. There you go. That looks better. And now I'm going to clean it up by distributing and solving for x here. Okay, so let's distribute the 1/3 right there and right there. So you're going to have 1/2 x plus 1/3 times negative 1/4 is going to be negative, so minus 1/3 times 1/4 is 1/12, because when you multiply fractions, you multiply straight across. Numerator times numerator, denominator times denominator. Negative 1/12x plus 10/3. Why 10/3? Because it's 1/3 times 10, so 1 times 10 and 3 times 1 equals 5. Okay? At this point, what you're going to be doing is isolating the x. So what I need to do is put these two together, 1/2 x and negative 1/12 x. Those are like terms, so I'm going to put them together. Okay? To put them together, I need common denominators. So what is the common denominator for 1/2 and 1/12? 12, right? I can multiply the 1/2 times something over something to make it something over 12. I need it to be a 12. So what do I multiply by? That should be easy for most of you guys to figure out. You're going to multiply the first equation the first term, first fraction by 6/6, which will give you 6/12. Okay, so here's what it is now. 6/12x minus 1/12x plus 10/3 equals 5. Now I can put these two together. 6/12x minus 1/12x is 5/12x plus 10/3 equals 5. Now I can kick out the 10/3 by subtracting 10/3 from both sides. I'm going to continue over here because I'm out of space. I get 5/12x equals 5 minus 10/3. What you need to do there again is make them fractions. So it's 5/1 minus 10/3. Have a common denominator, so multiply the first fraction by 3/3. Which will give you 15/3 minus 10/3. 15/3 minus 10/3 is 5/3, so 5/12x equals 5/3. I am going to erase some of this work so that I can continue over here. So here's what I have. 5/12x equals 15/3 minus 10/3. 15/3 minus 10/3 is 5/3. So 5/12x equals 5/3. And I'm almost done. Get rid of the 5/12s by multiplying times the reciprocal of it, which is 12/5. 12/5. And there's your answer. 5 and 5 cancel, 12 and 12 cancel, so it's x equals, the 5 and the 5 cancel, so you have 12/3, which is 4. Your x value is 4. Okay, you're going to take that 4, you're going to substitute into either one of the original equations and solve for y, so you're going to plug it in right there and solve for y. Here's what we got. 1/4 x plus y equals 10. Plug in 4. 1/4 times 4 is just 1 because they are reciprocals of each other. So 1 plus y equals 10. And finally subtract 1 from both sides, and there's your answer. Y equals 9. It's a messy problem, but the solution is 4, 9. Okay, so let's move on to some word problems. Here, number 22. A woman's age is 3 years more than twice her son's age. The sum of their ages is 84. How old is the son? Okay, so right here we have two unknowns, right? The son's age, and also we don't know the woman's age. So we're going to call each one of those by a different variable. I'm going to say X is the son's age, and Y will be the woman's age. You could also use variables that match your information. For example, W for woman's age and S for son's age if you want to. Okay. All right. So now let's try to put that in an equation using the information that they gave us. The first sentence says a woman's age is 3 years more than twice her son's age. Okay. So if I start reading this slowly, it says the woman's age. We know what that is. It's Y. So I'm going to put a Y right there for the woman's age. Is means equals. 3 years more than, 3 plus, 3 years more than. Twice, that means 2 times, twice, 2 times, that's what those are parentheses, 2 times. Her son's age, we know her son's age is represented by X, so I can just plug in an X right there. And there's your first equation. Right away you have your first equation. Y equals 3 plus 2x. Second equation, read the second sentence. The second sentence says the sum of their ages is 84. The sum of their ages is 84. Sum means plus. So add their ages, X and Y, and you should get is 84. Okay, so your second equation will simply look like this. X plus Y equals 84. And there you go. You have your two equations. Okay. Now using substitution, which is what we're going to use, I can see that the first equation is already solved for Y. So that work is already done for me. All I have to do is take this 3 plus 2x and go and plug it in right here. Substitute it in for the other Y. Okay, so that's what I'm going to do. I'm going to take X plus Y. Instead of Y, I'm going to take out the Y and plug in what Y equals, which is 3 plus 2x. So that goes here. And I just simplify it. X plus 3 plus 2x. Now, since there is nothing to distribute, I really don't need the parentheses. So it's basically just X plus 3 plus 2x. Equals 84. So that's basically the equation I need to solve. Combine the x and the 2x together to get 3x plus 3 equals 84. Subtract 3 from both sides. 3x equals 81. 3x equals 81. And divide by 3. And you get x equals 27, because 81 divided by 3 is 27. You're going to take that x equals 27 and you're going to plug it in right there. Okay, so you're going to have on this equation y equals 3 plus 2 times x, which is 27, and then you just simplify that down. Y equals 3 plus 54, and so y equals 57. There you go. The question is, how old is the son? We called X the son's age, therefore the son is 27 years old. And if they asked us for how old is the woman, we would say y equals, her age is 57, because we got y equals 57. Okay, go ahead and try number 23 and 24 on your own. Once again, pause the video right here, do the problems on your own, then come back and check your answers. Okay, so go ahead and pause the video right now. Okay, so here are the solutions for 23 and 24. In 23, the length is 37.5 inches and the width is 12.5 inches. In 24, the weekday job hours is 25 and the weekend job hours is 15. Let me just show you guys real quick how I got that. The two equations are here. X equals 3W and 2x plus 2W equals 100. I'm talking about 23 right here. X equals 3W because the length of the rectangle is 3 times its width. Therefore, X equals 3W. I call X the length because I don't like to use L as a variable very much. It looks like a 1 to me, or sometimes it looks like a parenthesis, so I'd rather avoid it. So X is the length, W is the width. So the length is 3 times the width. 2 times the length plus 2 times the width equals 100. And then what I did is I substituted in 3W into X right here, got 6W plus 2W, solved, got the width is 12.5, plug it in, and you get that the length is 37.5. For 24, the two equations are X plus Y equals 40. X is the weekday job hours, and Y is the weekend job hours. And there's a typo right there. It should say weekend, not weekday. X is the weekday job hours, so X plus Y equals 40. The total number of hours that he worked between the two is 40. I took that one and I solved it for X, so I got negative Y plus 40 equals X. The second equation is about how much he gets paid. 20 per hour at the weekday job, so 20X. 18 per hour at his weekend job, so 18Y, total of 770. Take my value of X right here, in my expression, negative Y plus 40, plugged it in, and I got Y equals 15. Took that 15, plugged it into the original equation right here, and I got X equals 25. Okay, I will let you do number 25 on your own, because you get to choose one of the exercises that we just did, graph it, and then just check that they intersect at the exact point that you got as your solution. So for example, for number 13 to 15, 23, it should say 23, 22 to 24 right here. That's a typo right there. 22 to 24, not 13 through 15. In number 22, let's go back to number 22 over here. You should have an intersection at 27 and 57. In number 24, your intersection should be, at 23, your intersection should be at 37.5, 12.5. And in number 24, your intersection should be at 15 and 25, okay? So you might have to adjust your scales accordingly, but just check. If you graph them, you should get those same solutions that you got by substitution. Okay, here we go. We're going to do a little bit of elimination now. Okay, it says solve each system of linear equations by elimination and then check your answer. Okay, so let me show you guys 26, 27, and then I'm probably going to let you guys try the other ones on your own. Okay, so here we go. 26, x minus 5y equals 10, and 2x plus 5y equals 5. Now, for elimination, I don't want to split them apart. I like them that they are on top of each other. That is the way that we want to eliminate. Okay. The first thing you want to check for elimination is that they're both in the same form, right? The x's match, the y's match, the equal signs match. Okay, if they're not, you have to adjust them so that they're in the same form. So for example, if you have something that is in standard form, but you have something else that is in slope-intercept form, that doesn't work. They have to be in the same form. Okay. In these cases, they're both in standard form, so that's perfect. That works out. The next thing you check for elimination are the coefficients, okay? And looking at the x's and the y's separate from each other. For example, just look at the x's right now. Don't worry about the y's. I have 1x and 2x. You want these coefficients of the x to be the exact same number but opposite signs. That's what we want in order to eliminate. That doesn't happen here, right? This is 1x and 2x. They are not the same number. It's 1 and 2. Now look at the y's, and I have 5y and negative 5y. They are the exact same number, but opposite signs, right? They are opposites of each other, okay? That's what you want to look for. If you don't have that, you're going to have to make it on your own. But in this case, we already have opposites. Negative 5y and positive 5y are opposites of each other. Therefore, it's perfectly ready for me to solve, okay? What you do when you see that is you add the two equations together. You combine them together, okay? So here we go. X and 2x, I'm looking right here. Put them together and you get 3x. Not 3x squared, as some of you guys sometimes write. Your equal sign has to come down as well, okay? Don't ever forget the equal sign. The negative 5y and the positive 5y, since they are opposites of each other, will cancel. They make 0. They go away. And the 10 and the 5 make 15. So after doing all of those combinations, I get 3x equals 15, which is a very simple equation. I can just divide by 3 to solve. X equals 5. And look how fast that was. You're going to take that x equals 5. You're going to go back to either of the original two equations, doesn't matter, and solve for y. Okay, so go back to the original two, pick the one that you like the best. It really does not matter at this point. I'm going to choose the second one. 2x plus 5y equals 5. Plug in 5 for x. 10 plus 5y equals 5. And now I can just solve by subtracting 10 from both sides. I get negative 5, divide by 5, and I get negative 1. There's your solution. 5, negative 1. Okay, let's look at 27 now. X plus y equals negative 10. 5x plus y equals negative 2. Once again, the first thing you always check is that they match. They're in the same form. They are. They're both in standard form. Then you check the coefficients. 1x and 5x, those don't match. But 1y and 1y match. The only difference here is that the signs are not opposites. They are actually the same sign. We don't like them to be the same sign. We want them to be opposite signs so that they can cancel out. Okay, so what you're going to do is you're going to subtract one equation from the other one, which means that what you're really going to do is just multiply one of the equations by negative 1 so that you get negative x, negative y, and negative something or positive something. You're going to multiply all the variables, all the terms by negative 1 to make them opposites. Okay, and at this point you choose which equation you want to multiply. It doesn't matter because either way the y's are going to cancel out. I'm going to take the first equation, x plus y equals negative 10, and I'm going to multiply everything by negative 1. When I do that, I get this. Negative x minus y equals positive 10. Why positive 10? Because it was negative 10 to begin with. I multiply by negative 1, it becomes positive 10. What I really just did is just change the signs of all the terms. The second equation does not change. It's going to stay as 5x plus y equals negative 2. And that's perfectly ready now. The negative y and the positive y will cancel out. Negative x and 5x makes 4x. And 10 minus 2 makes 8. Divide by 4. And x equals 2. You take that x equals 2, go back to either of the original equations and plug it in. I'm going to use the first equation, x plus y. So x plus y equals negative 10. Plug in 2. 2 plus y equals negative 10. I'm going to subtract 2 from both sides. And so y equals negative 12. And there's your solution. 2, negative 12. Now in number 26, I didn't check my work, so I want to check my work on this one just to make sure that we understand how to check your work. When we say check your work, it means take your values and plug them into both equations to see that they're true. So here's the check. You're going to do the first equation, x plus y equals negative 10. Substitute in 2 for x and negative 12 for y. And all you're doing is checking that this is an actual true statement. 2 minus 12 is negative 10. That is true. Check the second equation. It's not enough to just check one of them. You have to check both. Plus y equals negative 2. Plug in 2 for x, negative 12 for y, and you get 10 minus 12 equals negative 2. And negative 2, not negative 12. Let's fix that right there. 10 minus 12 equals negative 2, and that is also true. Therefore, my solution is correct. Okay, go ahead and try numbers 28, 29, 30, 31, 32, and 33. Okay, try the next few. 28, 29, 30, 31, 32, and 33. Try them all using elimination. Okay, so pause the video right now. Go ahead and take your time to try all of those. Come back and see the correct solutions. Okay, so go ahead and try them all right now using elimination. Okay, here you go. These are the correct solutions for numbers 28 through 33. 28 is negative 2, 1. 29 is negative 12, 4. 30 is negative 3, 3. The solution is right here in blue, by the way. 31 is infinitely many solutions. You have to be careful on that one. The x's cancel, the y's cancel, leaving you with 0 on the left side. 5 minus 5 is also 0. When that happens, that the x's and the y's, or all the variables are gone, you need to ask if this is a true statement. This is true. 0 is equal to 0. Therefore, you say infinitely many solutions. If this was false, you would say no solution. Okay. 32 is another one that you have to be careful with. When you cancel here the negative y and the positive y, they go away. The negative x and the negative x do not cancel because they're both negative, which leaves you with negative 2x. The 1 and the negative 1 do cancel, leaving you with 0. And many times I see that people think, oh, negative 2x equals 0. That's not true, therefore there's no solution. Okay, this is true. Okay, it's telling you that negative 2x equals 0. So you still need to divide by negative 2 to get x equals 0. You take that 0, you plug it in, and you get y equals negative 1. So your solution is 0, negative 1. You cannot say no solution here because the x is still there. You only say that if there is no x, no y, all you have is negative 2 equals 0. Then you would say no solution. Okay, but here you have to solve all the way through. All right, and finally 33, you do get a fraction for y, which is negative 36 over 5. You could put that as a decimal, I guess, and you would write 8 and negative 7.2, okay, which would also be correct. Okay, so 34 and 35 will be the last ones in this part 1 of your video review, okay? Part 2 will cover 36 and on all the way till the end, okay? So 34, a plumber charges an initial amount to make a house call plus an hourly rate for the time he is working. A 1-hour job costs $90 and a 3-hour job costs $210. What is the initial amount and the hourly rate that the plumber charges? Okay, we're going to solve this problem. This problem can be solved by simply using slope-intercept form and figuring that out, okay? But we are going to be solving it using a system of linear equations. Okay, so watch. The question is, what is the initial amount and what is the hourly rate that the plumber charges? Okay, so I'm going to choose variables for that. For the initial amount, I'm going to use B because it usually represents our initial amount. So the initial charge, initial amount that he charges. For the hourly rate, we can use H or R for rate. Or you can use M because it's a rate of change, right? So using the information, a 1-hour job costs $90. Let's use that only. Let's concentrate on this. A 1-hour job costs $90. So if he's only working for 1 hour, 1 hour job, 1 hour, plus the initial amount, B, gives you a total of $90. 1 hour at H dollars per hour plus B, the initial amount, is equal to 90. Using that same format, I can come up with the second equation. A 3-hour job costs $210. So 3 hours, that'll be 3H, 3 hours at H dollars per hour, plus the initial amount that he always charges, gives you $210. And there's your system of equations that you can use to solve. Okay, 1H plus B equals 90, 3H plus B equals 210. Now I'm going to solve it using elimination. I see that I have B up here and B down here as well. They are not opposites though, so they would not cancel. So I need to make one of them the opposite. Multiply the entire equation by -1. I feel like the easiest thing to do here would be to multiply the top equation by -1. So that means change all the signs. So it's going to look like this now. Negative H, or -1H, which is the same thing, minus B equals 90. The bottom equation does not change. 3H plus B equals 210. Oh, I made a mistake. -1H minus B equals -90. That was a rookie mistake that people make, and I just made it. Okay, you got to make sure you multiply the -1 times every single term in your equation. All right, so here we go. The negative B and the positive B cancels. The negative H and the 3H makes 2H. 210 minus 90 is 120, or -90 plus 210 is 120. Divide by 2, and there you have it. H is 60. What does that number represent? H is the hourly rate, so he charges $60 per hour. We also need to figure out what the initial amount is, so we're going to take this H equals 60, go back to either one of the original equations and substitute it in. I'm going to substitute it in right here into 1H plus B equals 90. So it'll be 1H, or 1 times 60, which is just 60, plus B equals 90. If I lost a couple of you guys here, all I did was plug in this 60 right there. So I got 1 times 60, 60, plus B equals 90. Okay, subtract 60 here, and I get B equals 30. And there you have it. The initial amount is $30. Okay, I will let you guys try 35 on your own first. So go ahead and try it. Pause the video right here and then come back once you're ready to check your answer. Okay, pause the video now. Okay, so here's the correct solution for 35. I chose to use A for the number of adult tickets and C for the number of, the cost of the adult tickets, and C for the cost of the child tickets. You could use X and Y also if you want. Okay, I decided to go with A and C. So using those two variables, my equations are A plus 3C equals 40. 1 adult and 3 children is $40. And the other one is 2A plus 3C equals 53. 2 adults and 3 children is $53. Using those two equations, I canceled the C by subtracting one equation from the other. So basically, I multiplied the top equation by -1 to get negative A minus 3C equals negative 40. Put them together and I got A equals 13. Take that 13, plugged it in right here, and I got 13 plus 3C equals 40. Solve for C and I get C equals 9. So my child tickets are $9 and the adult tickets are $13. The question is only asking how much is the child's ticket, so you really would only have to put $9 for children's tickets. Okay, and this concludes part 1 of your review. Okay, there will be a second part posted very soon that will cover problems number 36 all the way until the end. Okay.